the Energy Committee. Moving on. Item number 1, the Meadowlark Reclamation Facility Systems Overview.
So that's all we have is one item today, and this is an issue that we've dealt with before. We've received questions from numerous board members and on occasions from the public about the functionality of Meadowlark, so I thought it'd be a good opportunity to run it by the engineering committee and make sure everybody understands what it does, what it doesn't do, and what would be entailed if we were to consider to discontinue usage of the Meadowlark. We're not looking for any direction today, it's just purely an informational piece. So I'm going to turn it over to somebody on that side.
I'll take the lead on this. Okay. This is brought up by more than once, and we started putting together a very kind of straightforward presentation, and then it kind of got put on hold. I forgot when it got put on hold, but it was quite some time ago.
Yeah, it was back in June 21st of 2017.
Okay, so then I found the old presentation, and then I was able to revamp it. And so it's all the numbers are fairly high level. Both Rob and Ryan got involved to help me refine the numbers, looking at our master plan numbers, looking at some recent cost estimates. But they're all high level cost estimates. Some of them are probably too low, actually, but they're based on estimation, they're the best numbers we got now. So MRF system overview. So today I'm going to be going over the service area overview for basically our district, not just MRF. The system overview, which are the inputs and outputs into Meadowlark. What would happen if we decommissioned? What steps would we have to take? Our EWA treatment capacity, because obviously the sewer just doesn't disappear. So what would we have to do with it? Offsetting costs. There are savings if we were to decommission MRF. But there are offsets compared to what we'd have to do to build to decommission MRF. And then summary of costs to kind of sum it all up. There's actually one more slide of other items too that I'll go over. So with that, here's our district. And our districts kind of have, from a sewer standpoint, has 3 distinct areas. We have the largest area, which we call our EWA sewer shed. This is the area that naturally flows to Encina. And the second area is a small basin which naturally flows towards Lake San Marcos. So our Lake San Marcos really lift station sewer shed. And the third area naturally flows to Meadowlark. That is sewer generated there, flows downhill to Meadowlark.
Is that primarily San Leo?
San Leo, La Costa, basically from the ridge line, the ridge line on south, from the ridge line south, and into La Costa Oaks area.
Where does Lake San Marcos shed to?
Lake San Marcos, to the sewer lift station. So within the EWA sewer shed, we have one sewer facility, which are LS1.
Mm-hmm.
In Lake San Marcos, we have the LS2, or the Lake San Marcos lift station. And then obviously in the Meadowlark shed, we have Meadowlark Reclamation Facility.
So LS2
and LS3, you're right.
LS2 pumps directly into the line that's
to
going.
Meadowlark, pumps directly to Meadowlark.
Oh, it pumps directly to Meadowlark.
Yep, pumps directly to
Okay,
Meadowlark.
and
We'll show a schematic.
Yep.
Oh, okay,
of
good.
the
Yeah.
plumbing later.
So, actually, here's the schematic. So,
See, it wasn't much later.
so if you look at this, right, you have the 3 circles, which represents those big circles that I showed before. Obviously, they're not to scale. This is
Right.
Encina, Lake San Marcos, Meadowlark, and here are the facilities that we're really talking about today. So our outfall is a solid line, goes all the way to EWA. Right? You have Lake San Marcos LS1, which scalps off the outfall line and pumps it down to Meadowlark. You have LS2, which takes the sewer drainage that naturally falls towards the lake, collects it, pumps it to Meadowlark, and then out of Meadowlark, and of course you have the bypass line too. This is the bypass line, the one that broke. This we could use the bypass line to move sewer from here into the outfall if we need to. And then out of Meadowlark we have a solids line that goes out. We have also the fail-safe that goes all the way to the ocean outfall, and obviously the solids line goes in, and the secondary effluent line goes into our fail-safe also. So
the primary delivery is back around to the line going to Encina.
the primary delivery for Meadowlark.
Yeah.
For primary delivery for Meadowlark, stuff leaving Meadowlark is actually our recycled water.
Yeah, but where does the effluent go? Primarily from
From metal
Metal.
You're talking about the solids line, because that's all
Yeah.
these. Unless we're pumping a failsafe, the only thing that's going
It's
to
fails.
EWA is the solids line,
Solids
which
line.
is the middle one there.
This one
So
right
everything
here.
else is reclaimed.
Yeah,
yeah,
100%.
the solids go back and then it goes to the
Yep.
To
yeah,
EWA, and
yeah.
it has to be
Yeah.
treated
Yep.
at EWA.
That's why our EWA capacity is higher for solids than it is for liquids. It's 10.4 or whatever for solids and 7 point something for liquids.
And the fail-safe line, what is that used for?
Fail-safe line is used to pump secondary effluent, so it's treated to primary and secondary.
Uh-huh.
So if we don't need to produce recycled water, but we still have our local flow sewer coming in, we have to do something with it. Nobody wants recycled water.
Storage is full.
I see.
Storage is full. We treat it to secondary, which is ocean disposal
Right.
legal, and we pump it
It bypasses even.
Yeah, okay.
all the way to here. And this is actually a picture of what it actually looks like in real. So if you want to look at it, it's color coded. You see the different lines. But basically, that's a schematic of what it is. Obviously, I didn't take this picture all the way down to Encino because then the scale would be really small. So here's the existing facilities. I grade them out on the system overview. So as we move forward, if we need to decommission things, these are kind of the steps we need to take. We need to demo some lines. You know, you can't just leave empty lines in the ground if you're not using them. You have to fill them with concrete, sever them. They become hazards. They could collapse, create sinkholes. You need to make sure that you leave them in a safe space. So first thing we do is we demo LS1. Now, what I mean by demo and this cost of demo is not getting rid of LS1. It's severing everything, getting all the biohazards out, separating out the plumbing, and making sure it's safe, so it doesn't become a vector issue, a bio issue, or we don't have hazardous material, noxious gases, stuff like that. Electrical, mechanical equipment's being removed. LS1 is still there, so we're not digging it up and removing it.
What-
That's the cost.
All the elimination that you're talking about is the elimination to
Make it-
Divert the flow. We could no longer divert the flow.
right, but I mean, it still has a pump station, still power to get it going.
Nope,
We don't need
At
it.
all, we don't need it at all.
You don't
It's
need
all
it all.
gravity.
it's all gravity.
Oh, it's all
The
gravity.
only reason you need the lift station is to take it out of basin and take it to metal.
Yep.
Otherwise,
Okay,
it's 100%
all right,
gravity.
great.
So you're moving it from this circle to this circle, right?
What?
I don't know what my
I
mouse is on
can't
this
see
today.
that, whatever you
Yep.
got. Okay.
So you're moving from this circle to that circle. That's why you need LS1. Because
Okay.
it naturally flows to here.
All right.
Okay? So the next thing. Oops. Why are we not moving forward? It went forward several times. Okay, here we go. Next thing is obviously demoing MRF. Again, removing mechanical electro equipment, just making sure the basins are, doesn't have vector issues, hazardous materials, stuff like that. Abandoning pipelines in place. Again, you can't just leave pipelines in the ground empty.
But let me ask you,
Sure.
when you say demo Murph, you're talking about flattening the
No,
whole area?
that's what I just said. It's
Oh.
just removing mechanical, electrical equipment, making sure there's no hazard, but it's separating out the piping, so this way sewer is not continually flowing into MRF.
The plant wouldn't look any different, really.
I'm sorry?
The plant really wouldn't look any different.
Ah,
It'd just be empty.
Just
It-
non-existent, big
you-
empty facility.
decommission. You walk
Skate
in,
park.
Yeah.
the pumps are gone. You walk in, the electric equipment's gone. You walk in, so on and so forth.
And Director Hernandez, same thing for lift station 1. It wouldn't be a clean, bare site. You'd still have the structure, you'd still have the wet well, all the
Underground
So,
structure would still be there.
yeah, if you
That's right.
did that, these numbers would go up. You could put ones in front of these.
Yeah,
you know.
well, that's where I was going with
Yeah.
all this.
Yeah, so I'm just saying this is just bare minimum to get the site in a condition where it's mothballed.
Yeah,
Yeah.
okay.
Okay, so step 2, you'd have to build some new facilities. So basically, you'd need a new MRF lift station. We still have local flows coming in. Peak flows are projected to be close to 5 MGD. So you're talking about a $5 million pump station, or 5 MGD, roughly, $1 per MGD.
So, would you take the pump station that's at LS1 and move it to,
No, this is a whole
Bigger,
brand
neater?
new, Those
No.
pumps,
Wouldn't be able to handle
the
it.
profile of the pumps, the amount of this has to elevate a lot more.
uh-huh,
So LS1's up here, Meadowlark's down here,
Uh-huh.
and you got a small little hump over by, just on Rancho Santa Fe to get over. So LS1 is a medium flow. It's not. It's basically about a 2.5 MGD pump station at most. It doesn't quite pump that much, but and it has very little elevation to overcome or head. This would have a lot more elevation to overcome, and it also have more than twice the flow.
Okay.
So this is a significant size pump
Yeah,
station.
it's a completely different type of pump.
Yeah.
All right.
New force main. You got 7,800 feet of force main that you have to build basically up Melrose and connect it to our parallel land outfall. So it's about a $5 million job also. You would have to rehab the existing gravity main, basically the bypass line. You'd have to rehab it because now you're going to be pumping into it all the time, change the plumbing, rehab it because it's techite. So it's not going to be it's not good for everyday use. So another 1.7 million.
So, just to back up a second, you said you had to build a new force main in Melrose. You can't use the existing solid.
It's 6-inch.
It's
Oh.
6
Can't
to 8
handle
inch.
it.
Yeah.
Can't handle
Yeah,
the flow.
You're gonna
Yeah,
have to
it's a
really
six-
upsize
it's
it.
a
Unless you want to blow it up.
It's a 6-inch and it goes to 8-inch gravity line. Yeah, so.
It'll self-excavate
Yeah.
for sure.
I mean, you gotta remember our solids flows are point
Half an MGD.
0.5, yeah, 0.5 MGD. So then you got the new outfall, and the difference in the outfall, we have some savings on the other side. It's about $60 million in outfall because now you have to build more sections. There's sections that we wouldn't touch, but now you got an additional 5 to 8 MGD of flow that's not going to MRF, going into the outfall.
And the difference, because in our capacity, we saw the outfall being about 43 million.
Yeah, a little less, but yeah.
Yeah, and so now it's 60.
Yeah, because now there's sections of the out. Because basically what we do is Meadowlark can handle up to 8 million gallons a day of peak wet weather flow, which takes pressure off the outfall.
Yeah.
Now you would put all that into the outfall, so it would not only make the pipe size bigger, but sections that you didn't have to touch, now you'd have to touch.
Okay.
And depending when you took Meadowlark out of operation, you'd have to accelerate the construction of those things.
Yeah.
Yeah, and I want to be clear about that, and I kind of touched on it right at the end of the presentation. I didn't do like a time value of money, but the outfall project would be accelerated significantly because some of that stuff we're not building for 20 years, and just
Yeah.
doing like just quick calculations, we'd have to build it in the next 10 years. So it's accelerating it by quite a bit.
Okay.
And in EWA, we do not have the liquids capacity at EWA because we have liquids capacity at Meadowlark. So we'd have to go and purchase liquid capacity in the tune of $59 million. That's based on the RBA. So based on the RBA, that's what the cost of liquids capacity is. So
And that's how much additional? Compared to-
5
Yeah.
5 million gallons. Yeah, it's roughly $10 a gallon. So here's our cost when we add them all up. So basically, when you add them all up, you're looking at all the direct expenses being about $132.8 million. You do have some additional EWA O&M costs because now you're upping your liquids portion by 5 MG. You're taking the pie's the same, but you're taking a bigger piece of that pie. And going over our numbers of EWA, and this is a very rough estimate, it's somewhere between 1.3 and 1.5. So I just put 1.5 down. So, and then the new MRF O&M lift station. So O&M on the new MRF lift station, that new 5 MGD lift station, based on what our O&M costs are on LS1, which are close to $400,000. This one is obviously more than twice as big. I just extrapolated it out. So there may be a little bit of cost
A lot of
savings.
that's power costs.
It's mainly power
And you'd
costs.
have to have a much larger generator on site.
So, or reuse Goliath. Just kidding.
Yeah, and you'd have to constantly have that hooked up to
Yeah.
a toaster to run it.
So basically, you got about $2.5 million in additional O&M costs a year. Is the estimate. So you got direct costs about 132 million, O&M costs of 22.5. However, we do have some offsetting costs. So these are things that we wouldn't have to spend money on if we didn't have LS1 or MRF, right? So we have a bypass replacement cost. You guys saw that we were building a new pipeline. It was about 1.7. The replacement bypass replacement, which is just a gravity line to rehab it, essentially, is 1.2. The land outfall project, as Director Hernandez just pointed out, about $38.6 million in land outfall projects you wouldn't have to build. You have to build 60 million. So really, it's the delta that counts. And I'm gonna put I'll put the pros and cons together. You can see the deltas at the end. And we have various projects at MRF. Roughly $2.16 million of MRF projects on the books in the next 5 years that we wouldn't have to build. There's certain projects that we would have to build right now that are already moving forward, because and I'll explain why. So your offsetting costs are about $42 million that you wouldn't have to build, and then operating costs at MRF is about $1 million savings. So MRF's total operating cost, if you look at our budget, it's about $2.7 million, but we recoup basically MRF, MAR, and LS1, all three facilities are that now you wouldn't have to operate. The total operating cost is about $3.5 million, but we recoup 2.5 in sales, recycled water sales. So the difference is 1.062. However, our actual operating cost at MRF is about 1.8 of pure operating costs, because we recover a capital replacement of about 800,000, 760 or so in our recycled water sales. So that's why even though MRF is 1.8 and Treat and EWA is 1.5, because we're recouping that extra $700,000, that's why that number's lower. If that makes sense. So annual operating cost savings is about $1 million. So with that, you look at the summaries here. On the capital side, you got $42 million essentially of offsetting capital costs. You have $132 million in new costs. You're looking at about call it $91 million in capital expenditures. On the operations side, you're looking at a little bit over $1.4 million in operating cost increases to this, mainly because of this new large lift station that you're not getting recoup from. So LS1 doesn't cost us any money, essentially, is what it comes down to. And MRF is also significantly subsidized, because MRF labor and chemicals and equipment are being recouped through recycled water sales. So we don't really truly see the full burden cost of MRF by the tune of $760,000 being offset due to capital replacement that we collect from recycled water sales. So a couple other things. Timing would be 8 to 12 years to plan, design, and build the required infrastructure to do it. And you'd have to build all of it before you
Turn
did
it on.
Yeah. I mean, there's probably sections of the outfall you wouldn't have to build, but you'd have to build a significant amount of it. We'd have to probably acquire additional debt, or it would definitely depletion of our reserves would be an issue, because that's a different level that's not in our budgetary concerns right now, or in our budgetary forecasting. We have future DPR opportunities at MRF that wouldn't be realized if we kind of be letting go of that dream, whether it's a pipe dream or a real dream, but it's definitely something that's in the horizon.
Matter of flanged dream.
Flange dream.
Flange,
That's
flange.
pipe. Actually, we just met with Trussell Engineering on that very subject today, right before we got up there. Site development opportunities at LS1. On the flip side, LS1 is a free site to do some type of development on, and site development opportunities on MRF. Obviously, we'd still have to retain a large lift station there, but the rest of the site is essentially unutilized. So,
How many acres is MRF?
gosh, it's
5 point something?
that includes the slopes. I think the usable. It's pretty small. It's a postage stamp. For a treatment plant. It's a postage stamp lot. But
Yeah.
I thought it was like 3 point something usable.
Yeah, it's not
Yeah.
that
Okay.
big,
And
unfortunately.
So, and I don't remember what else one
And a
was.
lot of it's sloped, so.
LS one's like three and a third or something.
Yeah,
like
LS
that.
one's like 3 and a third. More of
Yeah.
it's usable though. So I think you're right. Murph is close to 5, but I think flat
Yeah,
area
usable is real
usable.
small.
So
So we don't have any money budgeted to take this, we don't have any plans or money budgeted to do anything different than what we're doing, which is to
Right.
continue to operate Metal Arc. But I just wanna make sure that the engineering committee was aware of what it would cost if it ever came up again in the future.
Right. Is that the end of the
yeah,
presentation?
that's it. That's all I got.
Is there any, I mean, and I don't have any desire, but I just to ask the question, is there any opportunity or desire for us to just say, hey, Olevenheim, why don't you take over, Murph? You deal with it. And
No, we haven't talked to them about
It'd
that.
have to make sense to them financially.
Yeah.
They don't use enough of the
I
water.
don't know how you'd make.
Pardon?
it'd make
They don't use
sense.
enough of that water
They
to
don't.
make
They
something.
use
No.
20% of the water.
and Carlsbad uses a bunch, but not
80%.
80%.
Yeah.
Of the recycled water generated.
Well,
So,
would Carlsbad be interested in taking it over? Is any? I mean, not that I, because I'm more interested in the DPR opportunity.
Right.
But if it came up and Carlsbad said, well, heck, we're doing it, why don't we just take over the operation?
I mean, more likely, Encina would be more likely a partner to take it over Carlsbad is what I would think.
Oh, really?
Yeah.
Well, Encina would be interested in taking over the operation and maintenance, but not necessarily the ownership.
Yes.
Just like they do other remote facilities.
Uh-huh.
So I've talked with Steinlich about that in the past, nothing recently, but he said that's something that they would consider if we were interested. But
What would that benefit us?
not, I don't think so. I
Oh,
mean, we'd
okay.
have to look at the numbers, but they would have to put together a proposal of what they think it would cost them to staff it.
Yeah.
I mean, most of the operations are gonna be the same, so like the energy and all that's gonna be the same,
And
whether
it's
it's
passed
them or
through
us.
each agency anyway.
It's
Yeah,
passed through
yeah.
100% to us.
There's
Yeah,
gonna be
just come
6
right
of
back
one
to
hand,
us.
I mean, their
Yeah.
employees, our employees,
Yeah.
something.
Yeah, I don't see any benefit to doing that.
Okay, okay.
And is regarding the other thing, if Carlsbad or Livenhain was interested in taking it over, if they wanted to initiate that conversation, we would certainly participate, but I don't see the benefit to us
Yeah, no,
initiating.
yeah.
Let's-
And so, hoping and looking forward to direct potable, does that have, well, I mean, obviously it's there, is there a significant amount of opportunity there, so that if it does come about, we go, oh, good,
Yeah.
let's do something.
Yeah, so everything we've been doing and everything that Glenn and I have been talking about and working towards at Metal Art, with every little project that we do there, still sets us up for future DPR. So, future DPR is it's going to be a highly refined water.
Mm-hmm.
So everything that we're doing, whether it's the new chemical addition systems, trying to get grant funding for expansion of the aeration when we put new filter media in it, is to be able to move 6.5 MGD through Metal Arc. So right now Metal Arc's permitted for 5, but the basins, the capacity of the system could handle 6.5 MGD of sewer,
Except for the CCT.
except for the chlorine contact tanks, which are original 1980 whatever 82 chlorine contact tanks. So that's the only piece that can't do it. So when we put new media in, it's sized for 6.5. We're looking at biological selector or aeration basins. They're gonna be sized for 6.5. In any other projects that we're doing in the future, it will be sized for 6.5. We're not changing the structure because the structure could already handle 8 MGD of wet weather flow, because that's what we need to take pressure off the outfall, which buys us time on the outfall
Mm-hmm.
and allows us to make the outfall a little smaller. So everything that we're doing is basically 6.5. Now, if we end up continuing with the recycled water agreements, that gives us 1.5 MGD of potential of treating towards advanced water treatment, which really means about 1 MGD of advanced water treatment. If the recycled water agreements become unfavorable and we decide to get out, now we have up to 6.5 MGD ability on the raw sewer side to create advanced water treatment for DPR, which would give us more of like a 4, maybe 3.8 MGD type of advanced water treatment facility. So there's that opportunity. The other thing that Rob and I are going to be doing here sooner or later, once we kind of get our heads above water, is looking at where those offsetting costs. Because if you have your own treatment plant that does water treatment, you don't have to build as much storage in certain zones. So, we have to build storage tanks in the future. That's in that big CIP that the board saw for the CAFE study. Well, if we had a DPR plant, then maybe we don't have to build some of those tanks. And where's that break-even line where, even if we build more DPR, we get no more offset. We're trying to find where those lines cross. Not crossing cost, but crossing benefit as far as offsetting benefits. And then try to find that sweet spot. And this way we could come back with a study back to Glenn, and then maybe a future study back to the committees and boards, which would make sense. good news is we got time, right? You know,
Yeah.
whether it's probably still the same, or DPR is the same timeline. And, you know, 8 to 12 years is probably actually optimistic, to be honest,
Yeah.
for DPR.
Yeah, I just started regulatory
Yep.
framework.
And I just met with Shane Trussell now on a different project in Meadowlark, and we were talking about the DPR timeline because he's on the committee writing the guidelines for it right now.
Do you think it's gonna be that long? I think it's gonna be 5.
I hope you're
Which
right.
is still
Yeah,
forever.
It'd be nice if it were.
Yeah.
I mean, look how long IPR took.
Yeah. They kinda got a mandate to do something now, so
Texas is building another plant.
maybe.
DPR plant.
Yeah.
They've already done it.
Yeah, but
Texas has.
Yeah.
but Texas has the California rules are different.
Well, they ran out of water too.
Yeah.
The
Yeah.
communities, they ran out of
What we
water.
need is another good drought by Godfrey.
It'll happen. You don't even
Hey,
need to.
oh, yeah, no.
Don't even need to knock on wood with that.
Oh, yeah.
If we didn't have desal, maybe you know. So,
Yeah.
but no. So the DPR opportunity is real, and the district could set itself up in one or two ways. Obviously, a smaller DPR or a larger DPR, and figuring out where that sweet spot is. We haven't figured out where that sweet spot.
If we had a grant for doing a pilot plant, would it be there
Yes.
at Meadowlark?
Yeah, but yes, the pilot would probably be there. I don't know if there's enough room to put a full-scale plant.
Yeah.
But you don't need to put the final water treatment on the same site. You
Nope.
can pump it off
It
site.
was
to
most
a
likely.
different-
Right.
James and I just kind of mothballed or threw it at the wall, spitballed it, and you know, Mar in front of the dam there.
Right there, where
right
we
there.
looked at for that
Yes,
fill
for the
station opportunity.
That's
Yeah.
like our only piece of property. You got the pipelines already right
Yeah,
there.
yeah.
You got power there, so I mean, you could. That would probably be the most logical place. Plus, you have Mar now. You line and cover it.
Sure.
Yep.
You know, storage facility right there. So
Mhm.
That could be your load equalization.
Do we have?
You could diurnally fill
How
it.
much area do we have in front of that mark? I don't remember.
Enough for
Small
a
package
plant,
plant.
for a package plant.
For a-
but the big deal about Mars, you could pump in diurnally as we treat advanced water. You could pump
Pump
it
it
into
into
Mar,
Mar.
and Mar will hold it,
Yeah.
and then we take it out at a constant
Nice
flow.
steady flow.
Uh-huh.
Yeah.
Which that's the important thing.
and you're talking about, you know, an advanced water treatment plant. You're talking about RO.
Yeah.
So there's less of a footprint for the plant.
Yeah,
It's not
yeah.
a conventional plant.
We're not
There's
talking
no said basins or
yeah,
anything.
acres and
I
acres.
mean, look how big Encina is compared to how big the
Desal.
Carlsbad desal plant is.
Mhm.
And
Yeah.
gives you an idea of scale differences.
Okay.
And
Well,
they both treat, well, actually, Carlsbad treats more MGD, so.
So you gave some numbers in terms of MGD, James, but in terms of how much DPR do we think we could produce in terms of acre feet? Are we talking 4,000 acre feet a year?
Yeah, on the high end.
Somewhere there? Okay.
Yeah, on the high end, maybe 5
Yeah.
is about the high end of it.
And we got 3,500 from desal, so
Yeah.
you're in the 7,500 to 8,000.
yeah, that's almost
in
half.
total. Yeah.
Yeah.
I mean, that's the things that are going to work against us are the amount of water that's being put down in the sewer,
Right.
and that's still yet to be seen with the new state rules.
And
Yeah. 55.
how would that
50,
offset if we put our plant there and then when Encina does theirs next on the south property?
Yeah.
I mean, that means we don't have to buy as much from them.
And there's less
Well,
pumping because you're gonna have to pump all the way from the coast to get it in. That's the biggest expense
Yeah,
on any of these.
there's-
Typically, it's going to be the energy.
Yeah.
So if we put a package plant at Mar, then you would put your solar that we've been talking about. That was the option 3 we didn't go with. You'd cover Mar in solar and at least offset some of your power costs right there.
Mhm.
So
'Cause-
EWA would have the advantage of economies of scale. Their
Right.
costs, but then they'd have to pump it up. So the cost may be about the same. Maybe I think we'd get a little bit of
yeah,
advantage.
you also have to remember that when you creates their advanced water and they put it into the aqueduct, you still need a treatment plant, a traditional treatment plant, but you still need a treatment plant to bring it out and use it. And if we still have desal in there, and I wish I actually this map's probably better. So this is the sewer, but if this was the water map, in that central zone along the 78 corridor,
Yeah.
we're flushed with water. We got a desal connection, an aqueduct
Pun
connection,
intended?
pun intended.
That's right.
We
Nicely
have a
done.
desal connection and an aqueduct connection, and we built a 33 and a 40 million gallon tank up at Twin Oaks. Primary reason we built those tanks because it serves water to the valley. So if you look at it, we have abundant storage and 3 water sources coming into where about 80% of our population live.
Yeah.
You know, so that's good news. When you get on the other side of the hill, on the other side of Lake San Marcos, we have 2 connections, right? We have an aqueduct connection and we have a Livenhain. So if we did a DPR plant, we'd have a 3rd connection in that area. We'd obviously be taking nothing from CWA probably on a normal basis, and we'd probably minimize our Livenhain take because we have to utilize our own systems. But the systems, although they're connected, it's adverse to go from one side of the hill to the other because you have to pump over it.
Yeah.
So, but here's the good news: is you do have the ability, if we were to pump it, and I've thought about this fairly in detail. We have those metal arc tanks that are off of Rancho Santa Fe Road, above the metal arc treatment plant on the other side of the Rancho Santa Fe Road. We're building a new tank there, and so we're gonna have 3 tanks up there at one day. So if you were to actually build a small pump station up there, because that's 815 feet above sea level, and our Lake San Marcos area is 855 feet over sea level. So it would be a high flow, low elevation pump station, and we have to do a little bit of plumbing upgrade because there's plumbing, but it's a small pipe. We'd have to make the pipe bigger. We could actually feed DPR water into Lake San Marcos area, into the 855s, as well as the San Leo area. We'd be with the pump station. We'd be able to pump it to the 877s basically. So be able to pump it to the first tank in San Leo, and then from there we have existing pump stations. They just go up the ladder.
Just pumping the pipeline for us, all to the authority, man.
Yeah.
Boom, cha-ching.
You really want to get in bed with him on a water purchase agreement?
We already are.
Yeah, how's that?
May as well get some money back, right?
So what you're looking at, yeah, that's true. What you're looking at is you have options then, so you could actually utilize the water because there's no way you could build a treatment plant that's got expensive water like DPR without utilizing every drop of it, because if not, you'll never get that economy of scale.
Yeah.
So basically, the water coming in from Ewa, if that became an option for us, it wouldn't be practical to use on the other side of the hill anyway. So there's a few things we have to balance out: is how much water can we take during a minimum month? You know, how much, and from our sources, what are we contractually obligated to take? Where do we store it? And you know, what are our offsetting costs? And I think when we start putting all these parameters together, even if we have the ability to produce 5,000 acre feet, the number might be like 3,200 or 3,500 before we hit a point where between all of our obligations,
Yeah.
we're maxed out.
If you look at just our demand, but we could reach out to a Livenhain or Carlsbad and see if they want to buy DPR water from us too. So there's probably a market.
Mm-hmm.
Would there be a possibility of they're doing a groundwater study? Could you incorporate it into that project?
They're on the other. It's on the other side. It's on the San Diego
Yeah,
River Basin.
okay.
It's on the other
Way
side
down
of their.
there.
Yeah, it's on the south side of their district. So, be hard to do.
Question, Director Martin was interested in this at one time, this analysis. Has he seen this yet? Or?
He has not. So, and that's the date I mentioned earlier. So Director Martin had brought this issue up a while ago.
Yeah.
We had been working with engineering. We were on the precipice of going to the board to get a contract award. And then on June 21st of 2017, these are the minutes of the meeting, that's when Director Martin withdrew his request. He said he doesn't see the need to spend more money to look at this. So at that point in time, it just kind of went quiet.
So staff put this together. Like I said, the numbers are just preliminary planning numbers. Some of them are probably low, to be honest. But they give you a sense of scale of what we're talking about. And I knew that the capital side would be way upside down. You know, close to $100 million upside down was my guess.
Yeah.
So it came in at 90 something. And I thought the O&M side would be fairly close to break even. I knew that we may save a little bit between treating at EWA compared to treating at MRF, but I knew that that'd be offset by operating a large lift station. However, what I didn't realize was how much our treatment at MRF is subsidized through our recycled water cells. So that's what causes it to be really upside down.
Well, good. Well,
That's all we had.
that's enough, you know?
Thank you.
Good, we got the information, let the sleeping dog lie until we decide what to do, but I think the reason Hal pulled it off was he found out it was gonna be an expensive
Yeah,
issue.
we had had conversations with him kind of behind the scenes, and I think he saw the handwriting on the wall.
Yeah,
And he knows the magnitude of it, I think.
I don't know if he does.
Yeah,
I don't think
He knows
anybody
quite
knew, but
worthwhile
it was
to see that.
more than a little bit.
Really, I didn't really have a good feeling. Both Rob and Ryan, they both put these numbers together for me at the end of last week because I had the base presentation with a bunch of blanks.
Yeah.
So they filled in the blanks for me basically at the end of last week, or else I had kind of had a guesstimate, but I didn't really know. So
And we're bringing this back to the board just for information.
That, we won't even be bringing it back to the.
Oh,
board.
okay,
Unless,
so-
unless the committee thinks.
That's why I asked. I think it would be helpful if he knows the magnitude of it.
Yeah.
I don't know if it necessarily has to go to the board, but.
No, what I would recommend is maybe when next time I meet with Director Martin, I can go over these
Yeah.
numbers
Yeah.
with him. If he feels a need to take it forward,
Fine.
then we can
Yeah.
talk about it. Otherwise, just let the sleeping dog lie.
Yeah,
Right.
okay.
Well, will that just be in the minutes?
It'll be in the minutes.
So yeah, the numbers will be there. Everybody can look at
Oh,
it.
yeah, yeah. And, yeah, the minutes of the engineering committee.
yeah, definitely.
Okay, great.
He always likes to keep an eye on what you guys are doing. So.
Yeah. Okay. Well, if that's all,
That's it.
you need adjourn.
Thank you.
And-